Hello, everyone. Once again, I'm speaking to you from beautiful Lynchburg, Virginia, and it's just about supper time. But I wanted to make a quick video because this time the content of this video is going to be for Algebra 1, even pre-algebra, depending on how advanced you are with linear equations. We're going to be looking at an equation that, at first glance, you might not recognize the type of equation it is. You might be somewhat, if you're an algebra 1 student, that is, or you're a pre-algebra student, you might be intimidated by it. But we're gonna talk about a mathematical way to handle we're gonna be talking about I don't want to give it away just yet, but when we start out, I want you to first try it and then see what you come up with. Tell me in the comment section, put a pause on the video, obviously, and tell me what solutions or what your method of manipulation was. And then we'll talk about, of course, in the video, how to solve that. All right, so the equation that we were going to be discussing, I'm going to write it on the board, and it looks like the following. We're looking for the value or the values of x that satisfy the following equation. Let's say you had 3 radical x minus 2 equals 30 minus radical x. So what we've got here is we don't have an ordinary equation. It's um, it's kind of cunning if you think about it, right? And a lot of students, the first time that they encounter an equation like this, especially at the pre-algebra or algebra 1 level, they don't like to see the radical symbol. They don't like to see it. And they kind of like move away from it. They either skip the exercises or, a lot of people used to do that when they were a child, weren't they? Goodbye, nasty world, right? You cover your eyes, you don't like something. And, at first glance, it might intimidate you with its radical airs. Lord knows I don't get intimidated, but I certainly don't like when it comes to individuals. Some people have too much of a radical air these days, and and some of them are, they're just as imposters, as I say. But beneath the facade, we have here a type of equation that is just waiting to be unveiled. So first, I want you to think about the equation. I want you to pause the video, do it on your piece of paper. Please do not use a calculator. Right? Please don't contaminate things with your calculator. Just do it on paper, do it mentally, and then we'll talk about it. All right, did you pause the video? So, when you are faced with complexity, a gentleman or a lady simplifies. We got to simplify things sometimes. We got to be straightforward about things sometimes. So we can introduce here something called, there's a method in mathematics when you're not sure what to do with the radical x term. And you can always change the appearance of the equation to make it look a little easier on the eyes. And this method, if we let radical x be a variable instead, right, it's called the method of substitution. And I haven't seen a lot of, at least in my area, but I could be, mileage may vary. I have not seen a lot of instructors cover the substitution method for these types of equations. Normally, what the instructors do, actually, we'll start out with the traditional sort of how the instructors teach this in many places. So we follow the method of isolation. Just as you isolate the variable when you're solving linear equations, you can actually isolate the radical x. So your first step would be your instinct might tell you to get all the radical x terms on one side by adding the radical x to both sides, right? So you would have something that looks like this. If we move this radical x to this side, it's called transposition, by the way, to transpose, we now have 3 radical x plus radical x. And that's going to, of course, if we move this to the other side, this negative 2, we have 30 plus the 2. And what you've got here is 4 radical x equals 32. right? This, when you combine the like terms, 4 radical x. Now, I had students ask me, wait, how did you get 4? If there's just, there, remember, when you don't write out their coefficient here, there's really a 1 there. I'll put a little, maybe I'll use blue this time so you can see what I'm talking about. There's really a 1 here. We just don't normally write it out. So these are actually like terms. Why? Because they have, in order for something to be combined with like terms, they have to have the same variable parts and or literal parts, and they have to have the same coefficient. So the 3 and the 1, they both share this, the radical x. So we now have 4 radical x equals 32, and put blue here. And what we'll do is, when we solve this equation, we have radical x. Remember, when you isolate this, you have to divide now by 4 on both sides. If we divide by 4 on both sides, this gets rid of that. 32 divided by 4 gives me 8. So now I have radical x equals 8. And when you have a radical, remember, you always, when you have an equation, you want to do the opposite of what is given to you in order to isolate. So in this case, you can square both sides to get rid of that radical. And if you square both sides, you get x equals 64. And that would give you the answer. But of course, this is a legitimate method. But once you're able to recognize certain manipulation techniques, you can make your life a little bit easier. And that's what we're going to do now. We're going to use something called substitution. So let's go back to the original problem. And what we'll do is, this time we're going to let y equal radical x. And something magical is going to happen. Let y equal radical x. And what that lets you do is, every time you see a radical x, you're actually going to substitute it with a y. So now your equation looks like as follows. 3y minus 2 equals 30 minus y. Isn't that beautiful? Now you recognize what just happened. We just found out that it was all along we had a linear equation. And you all already know, if you're watching this video, you should be in at least algebra 1 or pre-algebra. You already know how to solve a linear equation. Now it's just a question of adding y to both sides. If we move that negative y to the other side, we now have 4y equals 32. Isolating y, divide by 4 on both sides, and you get y is equal to 8. But of course, that is not the answer, right? We have to find x in the original problem. So now what you can do is you can put your value for y into y equals radical x. So now you can solve this, right? If you notice that 64 has a square root of 8, you can actually square, once again, both sides of the equation. So now you have 8 squared right? And then you've got your radical x here squared. And that gives you the solution that you were looking for. Radical x squared is equal to x. So you can always check, and of course, if you plug it in, you check your solution. Always check your work. 3 radical 64, right? It's really 3 times 8. 3 times 8 is 24, and minus 2 equals 22. And you're going to get the same thing on the right side. So it's really an elegant detour, isn't it? The substitution transforms what was an unruly equation, and we got a straightforward linear affair. And just like that, the problem has shed the disguise. We've shown who it is, and it's a very elegant way of looking at it. And of course, comparing it to the direct approach, which is fine. But what is the moral of the story? Well, in algebra, as in life, one of the key is to recognize form. Recognizing form is the key to simplicity. And what appeared as a radical mess, and heaven knows in this country, we've got a lot of radical messes going on at the same time, right? We've had, I mean, just last year, there were college campuses, I think, just last year and the year before, they were just filled with protests. Not a lot of learning going on in some of our college campuses. Thankfully, here at City Tutoring, we don't play that game. But appears, we had a radical mess in the beginning, and it turned out to be a humble linear equation in disguise. It was just trying to play adult game. And the substitution allowed you to solve it with a touch of flair that you can use. And let this lesson remind you that mathematics rewards the calm and the discerning. You have to use discernment. And, as any, back in the day, the Virginia gentleman knew, there is no finer way to meet a challenge than with precision and an appreciation for beauty in all its forms. Now, go forth and you can solve any equation that looks like this with confidence, because in mathematics, as in manners, clarity and order are virtues that are most sublime. In fact, even though it's getting a little bit late, why don't we do another example using our linear equation techniques? Why don't we do one with fractions, right? One that has fractional denominators, variables in the denominator, right? Supposing you had 3 over x minus 2, and we'll set that equal to 7 plus 2 over x. All right, so one of the first things here is, again, you got a little nasty thing going on here because no one likes to see in the denominator. No one likes to see variables in denominators. A lot of people, when they see fractions, they start tuning out. So, but the great thing is you can actually get rid of the fractions. And I've taught my students how to do that. We don't like fractions, so we get rid of them if we can. And luckily we can. We're blessed with that technique. If we multiply both sides of the equation by the denominator, you cancel the x's in the denominators of your fractions. So what do we have here? 3 over x minus 2. The denominator here is x, so we're going to do that. X times 3 over x minus 2. And we do the same thing on the other side. The other side, the denominator is x. So we have x is equal to, or x multiplied by, 7 plus 2 over x. All right? Now, we expand both sides here, right? So we have 3x over x minus 2x equals 7x plus 2x over x. So now your equation looks like 3 minus 2x and that's going to equal 7x plus 2. And again, I want you to see why, right? We got rid of the denominator. So this and this and this and this, right? In that sense. So we now have a nice linear equation. This is in fact a linear equation. So all you have to do now is add 2x to both sides. And if you add the 2x, you have 7x plus 2x. And now you have 3 equals 9x plus 2. And now all you have to do is just basically subtract 2 from both sides. And you get 1 equals 9x, which is 1/9. because if we divide by 9 on both sides, these 9's disappear, and we get 1 9 equals x. So, however, I have a warning for you. Whenever you solve an equation that has variables in the denominators, please check to make sure that your solutions do not make any of those denominators zero. Why is that? Why would I say that? It is illegal to divide by zero in the, you cannot have zero in the denominator, otherwise you get infinity. Some calculators will put, if you're using a calculator, it'll say error, but you cannot do that. And we could talk about why that is. There's a reason for that. And another way you can do this equation, by the way, is if you get rid of fractions last. How? By combining the like terms. And how do we combine the like terms? Well, once again, we'll go to the original problem. We have 3x and 2x, and 3 over x and 2 over x. And what you do is, excuse me, when fractions have the same denominator, you can either add or subtract them and keep the denominator the same. So you have 3 over x minus 2 over x. And that, of course, is going to give you 1 over x. And now you have 1 over x minus 2 equals 7. If you add the 2 to the other side, we have 1 over x equals 9. And when you are dividing, like this, you take the reciprocal of both sides, right? And you would find, once again, that x would be equal to 1/9. Notice, by the way, that if you take the reciprocal of both sides, it's really the same thing as saying that I'm multiplying both sides by x and then dividing both sides by 9. All right? So I hope you've mastered, at least the fundamentals, linear equations in disguise. And so equations in which a variable appears inside a radical, by the way, they're often solved by, you can raise the equation to the appropriate exponent. All right? So I hope this video was helpful. If it was, please hit that like button and help us out here at City Tutoring to continue to spread the message of pure mathematics, continue to restore order and discipline, and give our students the attention that they deserve. Because as I've said many a times before, you're being neglected. A lot of students, I was just this morning, actually, as I was taking my walk in the morning, I was walking around the grounds. There's a vast area of grounds around my property. And I was just thinking about this because I was just reviewing another book, which I'll review with you very soon. It's one of the modern mathematical math textbooks that they're using in the schools. And I was disgusted. I have to say, I was disgusted by it. Not a single mention of substitution. The exercises were very watered down. And no wonder test scores are so low in this country. And some states are doing a better job than others. But you look at places like, there was just the most recent report was one of the lowest states with one of the lowest, for example, SAT scores is California. I don't know what is happening, what's going on in the California system, but it's quite terrible, actually, what's happening there. You got to look at the if some of you are in California, please let me know in the comment section down below. Please let me know what's going on out there. What's going on with your school boards? What are they teaching? I know that in San Francisco, I believe it was, there was, I can't remember the name. I know it was some bureaucrat, but I can't remember. It was a woman. I can't remember her name though. But she said one of the most repugnant things I have heard in a very long time. She claimed that mathematics was racist. Can you imagine? Can you imagine what a disservice that is doing to the students? When in fact, math is actually the great equalizer. Because math is no respecter of persons. Math is about truth. It is about fundamental truth. It is one of the closest things that here on earth that is sort of developed by by human beings. It is the closest thing to the universal truths of the gospel. And to hear some of these incompetent fools say things like that, it just there should be consequences for some of these educators, I believe. But we'll see what happens, in the future. But all I can say is, if you feel that you don't have a good educational system, please continue tuning into this channel because we are going to bring you quality. We're going to bring you the actual, all the manipulation techniques and all the subjects. Have a great rest of your evening or day, depending on where you're located. And I'll call it a day for today.